Welcome to this series, or this video in a series of videos on the technologies contexts, that is the design and technologies curriculums, knowledge and understanding contexts. Today we're focusing specifically on engineering principles and systems. We will do another two sessions on the other two contexts. So it's important to understand that the technologies curriculum is unified around an overarching idea, that is creating preferred and sustainable futures, understanding the problems of today to imagine and create sustainable tomorrow. While discussing the different contexts, it is important to remember the overarching key idea of creating design solutions for a preferred and sustainable future. Together, the two strands, digital technologies and design and technologies, provide students with knowledge and understanding and skills through which they can safely and ethically design, plan, manage, produce, and evaluate products, services, and environments. That's a bit of a mouthful. Teaching and learning programs should balance and integrate both strands. So you will see in this design and technologies section of this unit, we are combining digital tools such as the different tools that we're using to brainstorm ideas with hands-on activities where students are creating and innovating and designing preferred solutions. Your future students learn about technologies and society through different technologies contexts, such as the one we're discussing today, which is engineering. So where to find the contexts in the curriculum? It's important to remember that when we are looking at the context, that is within the design and technologies, knowledge and understanding, the contexts are integrated. So for example, you're going to see both engineering and materials unified in these elaborations. So when you click on the design and technologies curriculum in the Australian Curriculum website, when you click on the plus sign, it's already been clicked on here, under Design and Technologies, Knowledge and Understanding, this is where you will start to see your elaborations for engineering and systems. But as I said, they are combined. You will see that food and fibre production is here as well, and the other context. And food specializations. Okay, so engineering principles and systems. What are the students going to learn in this technologies context? Engineering principles and systems is focused on how forces can be used to create light, sound, heat, movement, control, or support in systems. So when you're thinking about engineering, you're principally looking at light, sound, heat, movement, control, or support. Straight away, you're probably remembering the oven experiment that you might have seen done in schools, where students make their own oven or solar-powered oven with the use of different materials such as L-foil or aluminium foil. You might remember creating movement with different push or pull toys, which we'll discuss later. You might remember creating circuits that generate light with an AA-size battery. These are all part of the engineering principles and systems context, technologies context. Knowledge of these principles and systems enables the design and production of sustainable engineered solutions. That word sustainable will keep coming up all the way through the curriculum. Students need to understand how sustainable engineered products, services, and environments can be designed and produced as resources diminish. So students will progressively develop their knowledge and understanding of how these forces and the properties of the materials, so that's where that material specializations comes in, affect this behavior and performance of designed, engineered, and engineering solutions. So now I'm going to talk about, I'll give you a couple of examples just so you can get a tiny bit. Now this is just touching the surface, and to get you started to think about how you can integrate engineering principles and systems into your teaching. So the first example is looking at one of the elaborations, exploring how the principles of push and pull are used in the designing of toys. For example, in a spinning wheel such as an Aboriginal Mamanda. There's a picture, or a cartoon if you like, of a young Aboriginal boy playing with his spinning Mamanda. Think to yourself when you're looking at these images, how can I use these ideas and replicate them to help students learn the knowledge and understanding context of engineering principles and systems. Here are some more examples from the F2 curriculum with another elaboration exploring how to manipulate materials using a range of tools, equipment and techniques to create movement. For example, when constructing a toy boat that floats. You will see in this kind of a little bit annoying GIF here how they've used a fan and a land sailboat. This one here is a wind-powered car. Now, when you're talking about younger students, this is when these such students will probably need more help. But it can be as simple as creating a paper boat or giving kids a range of materials to see what floats on water. Once they get that object to float on the water, the teacher's job then is to ask them to think about how can they get that boat to move. For example, what sort of things could they add to their boat that would enable it to move? Now, in this curriculum, if their boat sinks, that's quite okay. Because what the students are doing is they're learning through their mistakes. So the different kinds of materials that you could give students in the F2 class are given here. Don't forget, recycling is a great idea. Using old push or pull tools that you can pick up from an op shop are great. So an example of the 3 to 4, you'll see some of the examples I've done and also some other examples. Wind-powered cars, slowly increasing the complexity of the design. A bridge that supports the weight of an object. A rubber band-powered car. So in year 3-4, the elaborations, I've just written 3 elaborations, and then I've given you an example that you can click on to a learning activity, a TED talk and learning activity that you could use with your students. So investigate how forces and the properties of materials affect the behavior of a product or system. Exploring through play how movement can be initiated by combining materials and using forces. For example, releasing a wound. So this one here, they would join the rubber band from this side to this side and they would wind it up, and when released, that would spin the wheels to propel a model toy. Identifying and exploring properties and construction relationships of engineered product or system. For example, a structure that floats, a bridge to carry a load, such as the examples given. In year 5 or 6, the students move on to investigating how electrical energy can control movement, sound, or light in a designed product or solution. Here you will see a very simple tractor that's powered by solar power, a house that's going to light up. There'd be a little tiny LED light underneath there with some copper tape, and how this is powering that solar panel is creating that solar panel. How that solar panel is being used to light up the light. This is all integrating science with technologies as well. So in this example, you can see there's a light bulb up the top, and behind this board is wires connecting each of these circuits so that when the young child clicks on this little button here, the stamen will light up and so on. If you haven't experimented or know about makings, that's another amazing little technology kit that you can use for students to generate, to experiment with circuits, lights, and electrically generated movement. So there's a link to a Vimeo video there that you can watch. Other ideas: use Google, sites like TES Online, and other websites to find amazing ideas. I even use Google Images to give me inspiration for my teaching ideas. Not everything needs to be complex. So much can be done with a piece of paper or foam or cardboard and so on, a small engine or old toys. And here's an example for you to click on. This one here, the older students experimented with hydraulics. And by hydraulics, they just used a syringe from the chemist, and when pushed, it would open the door, bringing us a kid's storybook to life.